So what is a better way to calculate the support? This method is what we call the a priori approach. So what is a priori? A priori is an approach that it proceeds by identifying the frequent individual items, starting with one item, and is basically a bottom-up approach. So the item that passes the minimum support in the database and extend based on that item, extend them to a larger and larger item set as long as these item sets appear sufficient often in the database. So basically starting with one item set, look through all data set and then find one item sets that pass the minimum support, because only if the lower number of items set can pass the minimum support, the higher number of the items built on those can have a possibility to pass the minimum support. That's the concept. So using the bottom-up approach, starting with one item set, use the items that pass the minimum support of the one item set, build a two item set, and then check all the item set based on that approach and find the possible combinations of the three item sets and go on. Until you cannot build up any candidates, then it is time to stop the support search. Let's take a look at the example and be able to understand what is the meaning of the a priori approach. So you can see that the data set that we put over here still stays over here, and then the support count is basically using the items that occurs together divided by the total number of transactions. So starting with one item set, since we have 5 items, let's try to see if there is something that has never passed the minimum support, then we don't need to include that item anymore. So for example, you can see that item 1, item 2, and item 3 occurs pretty frequently. Think about this. In this example, we have item 5 occurs twice. Item 4 occurs twice. Since our minimum support is 2 out of 9, 4 and 5 did pass the minimum support. However, if our minimum support instead of 2 out of 9 becomes 3 out of 9, think about this. If the minimum support is 3 out of 9, 4 and 5 occurs only twice in the whole transaction. That tells you that no matter it's 2 item sets, 3 item sets, 4 item sets, or even higher, as long as they contain item 4 or item 5, they will never pass the minimum support. If the lower number of items set cannot pass the minimum support, the higher number of items set, including those lower numbers, will never pass the minimum support. So let's take a look at this. Still, come back to our regular minimum support, which is 2 out of 9, and let us take a look of all the items. We have 5 items over here, understanding that item 1 occurs 6 times, item 2 occurs 7 times, item 3 occurs 6 times, 4 and 5 twice each. Since all of them pass the minimum support, we will want to use all of these to create all possible 2 item sets based on the 1 item set that passed the minimum support. Again, since all of them pass, we need to create all possible combinations, and therefore what we need to do is that we create the 2 item sets based on 1, 2, 3, 4, and 5. So this is the same step that we did in the previous example, previous slides. So we need to create all possibilities over there, and then based on that, we then now try to check 2 item sets. So in this case, what you can see is that for the 2 item sets, 1 and 2 occurs multiple times. 1, 2, 3, 4. So it passed the minimum support, and then we try to check all of those things one by one, understanding that 1 and 2 occurs 4 times, 1 and 3 occurs 4 times. So these 2 pass our minimum support. However, 1 and 4 occurs only once. So we will eliminate that and then look into 1 and 5, 2 and 3. 2, 4, 2, 5, and all other things are not passing our minimum support, and that's pretty naturally understandable. because 4 and 5 occurs only like few times, and therefore the items contains 4 or item 5 will have less possibilities to pass our minimum support. And therefore, based on all of these informations, we would understand that 1 and 2, 1 and 3, 1 and 5, 2, 3, 2, 4, and 2, 5, those are the 6 2-item sets that pass the minimum support. And using these, then we try to create what we call a 3-item set. And to create 3-item sets, it is actually not as easy as it looks, because you need to use 1 and 2 to merge with 1 and 3 while you try to merge the first 2 rules. Not only you see that 1 and 2, 1 and 3 passing the minimum support, you also need to check 2 and 3 to see if 2 and 3 is included in this list. In this case, yes, and therefore we are able to include 1, 2, and 3 to form a 3-item set over there. Then we will need to do the same thing. You can see that 1, 2, 1, 5. So if we will try to merge 1, 2, and 1, 5, we also need to see if 2 and 5 existing in this table. And to be look into this one, we see 2 and 5 is there, and that's how we can create 1, 2, and 5. Take a counter example. If we try to merge 1, 3, and 1, 5, and you see that we need to see if 3 and 5 existing in this table, which means that we want to see if 2-item set I3 and I5 existing in this table. We will realize there's no it's not there, and therefore we will understand that we are not able to create a 3-item set that's 1, 3, and 5. And you can see that these are the only 2 3-item sets can be created in this 2-item set that pass the minimum support. So by doing that, we will need to go into the next step, try to check what is their support on 1, 2, and 3. So if we look into the table, understanding that 1, 2, and 3 occurs only once over here, and then the second time over here. So basically, we will understand 1, 2, and 3 did pass the minimum support. 1, 2, and 5 on the other case is one is over here, the other one is over here. So we will understand both of them actually pass our minimum support. In other words, if our minimum support is higher, then we will not have any rules that including in the 3-item set. So once we are able to generate those 2 rules, the next step is that we try to see if we are able to use those 2 rules to generate a 4-item set over there. And the answer is no. Because once we combining these 2 rules, you can see that if we try to merge them and then form an item set of 1, 2, 3, and 5, that is to say we need to have another rules that has 2, 3, and 5 as a 3-item set that pass the minimum support. Since 2, 3, and 5 3-item set is not existing in this table, we will understand if the smaller part is not meeting the minimum support, the larger part cannot meet the minimum support, and that's why we will understand there is no 4-item set to be generated necessary. So we don't really do that step, and we can basically stop our support calculation over here. And therefore we will understand all of these things are not really even necessary to see. But if we really want to do that, we will understand that there's only occurs like once, so we don't really need to do that operation. And since there's no 4-item sets generated, not to mention we don't need to create a 5-item set, so that we can stop over here and then focusing on the rules that pass the support, and we will be able to work on the second part of it, which is focusing on the confidence. So if we try to put all the pictures in one page, you will understand that we try to create 1-item set, generates the candidates, creating the 2-item set candidates, check one by one every single candidate. We can rule out something that's not existing over there, creating a 2-item sets rules that pass the minimum support. Use that to create 3-item set, check those informations, and we would be able to find out that's when we we are able to stop going to the next stage. So this page gives you like a summary of the whole thing using our example and introduce you the idea of the a priori. If we look into the pseudocode, you will understand that we create two lists. First one is the candidate item, and then LK indicating the frequent item of size K. So starting with size of 1, you can see that starting with frequent item size of 1, and we try to see if there is anyone that's past the minimum support, so that we can use one item set to go through the whole process, generate 2 item set, 3 item set, 4 item set, 5 item set, etc. So you can see that this for loop is actually indicating the one item, starting with 1 item set, goes to 2 item set, go to 3 item set, and then until there's nothing left, we don't need to continue. Inside of this one, we try to generate the candidates coming from the LK. So if K is starting from 1, and then C candidate of 2 items need to be generated from the 1 item set, and then for each transaction T in the database, and then you try to look into every single candidate to see if that pass the minimum support or not. If that pass, we are able to add that into the frequent item K plus 1, which is say 2 item set. Then we can add those things over there, and now we have the base, and then we will go back to the loop to work on the 3 item set, and then we will go through the whole process, look into every single candidate, and then add the one that passes the minimum support. So this is like the loop to generate different number of item sets. And basically, after that is done, we will be able to return all of the frequent items that we can identify. So this is like the a priori pseudocode, so that can help you understand and also help you to think, what if you are about to write a program? How would you write a program based on these concepts? To make sure you understand this correctly, let us take a look of assignment. So in this assignment, it's actually even simpler because we only have 5 transactions. So now we have T1, T2, T3, and T4, and T5. Suppose they saying that our minimum support is set as 60%. Now look into the transactions. So think about this. T1, transaction 1, the item MONKEY has been purchased. T2, DONKEY has been purchased, etc. Something interesting I want you guys to see, transaction 5, and that can be reflected on the real daily life. This customer purchased C item, purchased 2 O item, and then 1K, 1I, 1E. So this is actually something really happening in our daily life. Maybe you go to Kroger and buy 2 bottles of milk. So this is something can be further extended in the research concepts. For the assignment, you can simply consider OO as 1O. So the customer who purchased milk. It doesn't matter if buy 2 or 3 or more. But you can see that in real transactions, you will be able to even have some items being purchased multiple times. And how would you want to add that into your knowledge? How would you design your research is something very interesting. Also, on top of that, every item has different prices. So think about this. If item C costs like $2, item O costs like $100, that item O is going to make more benefits for you. So these kind of things are extended versions of association rules can be discussed, and therefore it's interesting for you to think about all kind of possible things can happen in association rules. But come back to the class. Don't worry that too much for this assignment. All I want you guys to do is look into those 5 item sets, look into those 5 transactions, and then consider duplication as simply like one item has been purchased over there. Using minimum support equal to 60%, I want you to find all frequent item set using a priori. So that show me all the calculations, all the steps that you have been generated, and then tell me what are the frequent items including 1 item set, 2 item set, 3 item set, if there's any, or even higher. Now tell me what are those frequent item sets with the minimum support equal to 60%.